So the first question on our quiz is looking at derivatives of trig functions. And so part A, if we want to find the derivative of this one, so f prime at x is going to equal 2, and then the derivative of sine x is cos x, so 2 cos x. And then subtract 3. Derivative of cos x is minus sine. Sorry, derivative of cos 5x is minus sine 5x. And then we have to take the derivative of this 5x here, which is 5. So that's it. Now you can simplify that a little if you want to. So you can write 2 cos x. And a double negative gives us a positive, and 3 times 5 gives us 15. So plus 15 times the sine of 5x. So for part B, again, you can think of just this square root as simply putting brackets and making it an exponent of a half instead. So we're going to apply that chain rule then. And so the derivative would be multiply by a half, so we have 1/2, times everything in that bracket, don't change it, just x squared, plus the sine of 3x, and then subtract 1 from your exponent, so that becomes minus a half. And then we need to multiply by the derivative in this bracket, so x squared, derivative of x squared is 2x. Derivative of sine 3x is cos 3x, and then we have to multiply that by the derivative of 3x, which is 3. So I'm just going to put a 3 in front there. Okay, and we can simplify that a little bit. So on our numerator, we have this 2x plus 3 cos 3x. All divided by, you can put this 2 on the denominator, and that would be the square root of x squared plus the sine of 3x. So part C, similar to this one, we're going to do a chain rule here. So we're going to bring the 4 out in front of the brackets. So our derivative is 4 times that whole bracket, the sine of 2x, plus 1, and then subtract 1 from the exponent, so we get a 3. Then we have to multiply by the derivative inside the bracket, so sine becomes cosine, so we get the cos of 2x. Then we have to multiply the derivative of 2x, which is 2. I'm going to throw that in front here. And then derivative of 1 is 0, so that's that. So if you want to simplify a bit, 4 times 2 is 8, so we have 8 times the cos of 2x, all times by this sine 2x plus 1 cubed. So for part D then, our derivative is going to be, this is the sine of x squared, not the sine squared of x, but the sine of x squared. So the derivative of sine is cosine, so we're going to leave that. And then multiply it by the derivative of this function, x squared, which is 2x. And subtract derivative of x is just 1. So if you want, you can write 2x times the cos of x squared minus 1. Alright, let's try some examples with exponential functions. So for part A, we want to find the derivative of this function. So we have 5. Now the derivative of 3 to the power of x is going to be 3 to the power of x. And since that's a general exponential, we need to multiply by the ln of the base. So multiply that by the ln of 3. And then you would also multiply by the derivative of that exponent. Derivative of x is just 1. So we don't really need to write that down. And then minus the derivative of 7x is just 7. Okay, so that just gives you 5 times the ln of 3. That's our coefficient in front. Times by 3 to the power of x minus 7. We have sine of e to the power of x. So to find the derivative, first, the derivative of sine is cosine. So we're just going to write that, and we're going to leave e to the x alone. And then we need to find the derivative of this function, which is e to the x. And the derivative of e to the x is e to the x. Right? Now you could multiply that by the ln of e, but the ln of e is just 1. So we don't need to do that. So that's it for that one. Here's another one where we're mixing exponential and trig functions. So in this case, the derivative would be e to the anything is just e to that, in this case sine x. And then you'd multiply by the ln of e again, which is just 1, so you don't need to do that. But then you also need to multiply by the derivative of this function here, sine x. We did that in the previous function, but the derivative of x is again just 1. So I don't need to constantly show that I'm multiplying by 1. But in this case, the derivative of sine x is not 1, it's cos x. So there's your derivative in that case. So for our last example, you have a choice. You can either change x to an x to the negative 1 and put it on the numerator and use your product rule, or you can leave it on the denominator and use your quotient rule. I'm sort of a fan of the quotient rule, so that's what I'm going to do. Alright, so f prime of x equals, if we're applying the quotient rule, we're just going to do the derivative of this general exponential. So we'll just start by leaving it as 3 to the 2x minus 5. And of course we need to multiply that by the ln of the base, so multiply that by the ln of 3. And multiply that by the derivative of that exponent, where the derivative of 2x is just 2. And the derivative of negative 5 is 0. And then we multiply by the denominator, so x. Alright, next, subtract. Now we're going to leave the numerator alone, so we have 3 to the 2x minus 5. And multiply by the derivative of the denominator, which is x, so that derivative is just 1. And then divide by the denominator squared, so x squared. And that's it. We can make it look a little bit nicer. If we want, we can factor out this exponent, 3 to the 2x minus 5. Multiply that by 2 ln 3 times x. And then minus 1. I should specify this is not the ln of 3x, so let me put that in brackets there. It's the ln of 3 times x, all over x squared. Okay.